All right, let's just dive right in. Welcome everyone to today's Explainer. We are diving into a truly thrilling frontier in tech right now. For the longest time, we've all kind of been passive users of artificial intelligence, right? We rely on these massive servers sitting in a data center somewhere to do all the heavy lifting for us. But what if you could actually take control? Today, we're exploring the fascinating process of hosting and training AI models locally, literally right on your own computer. I know it sounds a bit like science fiction, but as we'll see from our source material today, it's completely possible, and it all starts with understanding just a few core concepts. So here is our roadmap for today. 1. Training AI locally. 2. Fine-tuning versus RAG. 3. Creating the Marvel dataset. 4. Saving as a JSON. And 5. Preparing the Llama model.
Section 1. Training AI locally, the paradigm shift. This whole concept really represents a massive shift in how we interact with technology. We're moving away from simply typing a prompt into a distant AI to actually pulling the strings and teaching these models ourselves. But before we can just fire up a powerful local model on our machine, we have to conquer the essential first step, and that's preparation. You can't just turn on an AI and expect it to magically know what you want. You have to generate and prepare a dataset first. Think of data as the fuel for the engine. Without properly structured data, your local AI is quite literally going nowhere. So how do we actually teach it?
Section 2. Fine-tuning versus RAG, style versus substance.
If you've spent any time looking into AI, you've probably heard these complex jargon terms thrown around. Well, let's demystify them. Let's start with fine-tuning. As our source explains perfectly, fine-tuning is all about teaching an AI model how to talk. It's about adjusting its tone, its delivery, and its overall personality. Think of it using this great lawyer analogy. Imagine you need an AI to talk to just an everyday common person. You wouldn't want it quoting Section 345 in dense legal jargon, because a regular person just wouldn't get it. But if that AI is talking to a legal expert, well, you do want that complex, professional tone. Fine-tuning is exactly what dictates that stylistic shift. It shapes the delivery. On the flip side, we have Retrieval-Augmented Generation, or RAG for short. If fine-tuning is about how the AI talks, RAG is about teaching the model specific new information. This isn't about personality at all. This is purely about facts. Going back to our lawyer analogy, if you need the AI to actually know the specific, updated legal codes and sections to reference in a case, you'd use RAG to inject that hard data right into its brain. Just to lock this difference in permanently, fine-tuning dictates tone and style, basically how it talks. RAG dictates facts and data, what it knows. For our purposes today, as we prep to train our own model to act and speak in a very specific way, we're going to be focusing heavily on creating a dataset built specifically for fine-tuning. Section 3. Creating the Marvel dataset, hands-on execution. Okay, we're actually going to look right over the creator's shoulder now to build some real training data. Using everyday tools like ChatGPT, this is the exact prompt used in our source to generate the dataset. Quote, "Give me a dataset of all Marvel characters from the Avengers, around 50, in the format instruction, input, and output." Notice how laser-focused this is? The creator explicitly mentions they didn't ask for characters from the Fantastic Four or the Thunderbolts. Why? Because keeping the scope tight, focusing just on the widely known Avengers roster, prevents the AI from getting confused and spitting out messy data. And look at the very end of that prompt. It demands 3 extremely specific things: instruction, input, and output. Now, these 3 mandatory columns are the absolute backbone of our dataset. You literally cannot skip these. They structure the raw text so that when the time comes, the local model learns exactly how to interpret a prompt and exactly how to structure its resulting response. And here is the resulting data. Just look at how perfectly the AI formatted this for us. In the instruction column, it might say something like, "Provide brief information for a Marvel character." Then the input column names the character, like Iron Man or Captain America. And finally, the output column contains the actual biography. By repeating this perfect 3-column structure across characters like Thor, Hulk, Black Widow, and Doctor Strange, we are basically creating a pristine textbook for our local AI to study from. Section 4. Saving as a JSON, the golden rule of formatting. You really want to pay close attention here, because honestly, this is where a lot of people stumble. We have our beautifully formatted Marvel data, sure, but how we save it is the most vital technical hurdle of this entire process.
The procedure itself is incredibly simple. Step 1, you just open a basic app like Notepad. That's right, no fancy coding software required. Basic Notepad is literally all you need. Step 2, you paste in that perfect 3-column data we just generated. Step 3, you save the file. But here is the huge catch for Step 3. The file, absolutely without exception, must be saved as a .jsong file. Do not, whatever you do, save this as a standard .txt text file. Our source was super enthusiastic about this, and for really good reason. JSON is the highly specific dataset format that these models actually require to function. If you try to feed it a regular text file, your model will simply look at it, not understand a thing, and your training will fail before it even begins. JSON is the key to the whole shebang.
Section 5. Preparing the Llama model. Looking ahead.
So we have our correctly formatted JSON dataset in hand. Now we connect it to our ultimate goal, feeding it into a powerful, pre-trained model to truly make it our own. The specific model highlighted in our source material for this task is Llama 3.2. It's currently one of the absolute best open source models available for this exact kind of local fine-tuning. We're going to take our Marvel JSON dataset and inject it straight into this Llama architecture. Now, you might be wondering, why do we even need to do this if Llama's already pre-trained? Well, pre-trained models can have outdated or even totally missing information. For instance, our source notes that an older or base Llama model might not have the latest context on a character like She-Hulk. By feeding it our specific, highly structured Marvel dataset, we're effectively upgrading its knowledge base and fine-tuning its delivery. We're transforming a broad, general-purpose AI into a highly specialized Marvel model. And before we wrap things up, it's worth noting what actually makes this high-level local computing possible today. Our source gave a quick shout-out to their sponsor, Oxygen. Brands like this are really pushing the envelope by providing AI-capable laptops, phones, and devices that actually have the raw processing power to handle these local datasets and run these models smoothly, right there on your desk. The hardware barrier to entry is dropping incredibly fast. So we've covered the theory, the hands-on dataset creation, and those absolutely crucial formatting rules, which leaves us with one final provocative question. Is your JSON ready for Llama 3.2? Because once that data is structured, formatted, and saved correctly, you literally hold the keys to training an AI that speaks exactly how you want it to. I really hope this explainer has shown you just how accessible local AI training can be. Until next time, keep exploring and get that data ready.